Okay, so today what I'm going to do is we're going to talk about resistance. Okay, but unfortunately, just like the other day, this set of PowerPoint is in Malay lah. Okay, but today not so much of notes, but today is more on calculation. Okay, so we're going to talk about resistance. Okay, and I want to focus on this one, 3.2.2, just for today. Okay, I want to talk about problems that involve series, okay, Lita sesiri, which is a series circuit, okay, and parallel circuit. You will find this in your notes as well, okay, right in front. Okay, 3.2.2 is my focus today because this particular subtopic has so many experiments that I cannot, you must do the experiment lah. Okay, I feel that it's so important that you all do this experiment, and I don't know why. Maybe you can call this a naluri seorang guru lah. Okay, I feel that it's very important, especially since this year you guys are doing paper 3 kan. I feel that you need to do this experiment in order to understand Ohm's law. But we're going to bypass this 3.2.1, okay, which has all these experiments kan. Kalau kau nampak page 89, page 90, all this, a lot of experiments, and then at the back there got graph paper lah, some more. Okay, so we will skip this first, and after your exam, then we will do this experiment lah. Okay, but I want to do this series circuit and parallel circuit today. Okay, but in order for us to do that, we have to understand what Ohm's law says. Okay, can you open your textbooks and tell me in English what is Ohm's law? What does Ohm's law say? It's in your textbook. It's one of the first things that you need to do. What does Ohm's law say? Okay, page 100 That's why, mana boleh tiada. Okay, Ohm's law states that the current through a conductor between 2 points is directly proportional to the voltage across the 2 points. Okay, but I'm going to this one. So Ohm's law states that the current, okay, you can use Iqbal's this one, but instead of using the word conductor, I want you to use the word ohmic conductor. Okay, you know what? I'm just going to, I can't type this here. Okay, so the current, okay, through an ohmic conductor. Okay, the current through ohmic conductor between 2 points also can lah. You can use the same words that are in your textbook. Okay, between 2 points, okay, is directly proportional, okay, to the potential. Is it potential difference or voltage? Okay, fine. I would rather you say potential difference. Okay, potential difference across the 2 points. Okay, across the 2 points. Okay, then the end of this is very important. Okay, there is a condition for this. Okay, if the temperature and physical condition, okay, either are constant. Okay. Please forgive me for my horrendous handwriting. Okay, so Ohm's law, okay, states that current through an ohmic conductor between 2 points is directly proportional to the potential difference across the 2 points if the temperature and physical conditions are constant. We will look more into this in our experiment lah, but I just need you to know the law now. Otherwise, nanti kan what we're going to discuss in a while will not make any sense lah. So I just need to tell you this first. Okay, but the key word okay, the kata-kata kunci, if we have a highlighter or something okay, is it's just this lah. Current is directly proportional to the potential difference. That's it. Okay, current is directly proportional to the potential difference. And yesterday we learned that current is given with the symbol of I. Okay, I don't know why my I is not coming out. Okay, is directly proportional to V. That's the singular most important thing about Ohm's law. Okay, Ohm's law states that current blah 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 is directly proportional to the potential. Okay, then blah 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 blah. Okay, that's the singular most important thing lah. Okay. Once you're done copying, let me know because I want to rub this off. Ada lagi gambar di bawah sini ni, so I need to rub this off. Yang saya punya tulisan buruk ini. Okay, can ah?
Okay, okay.
All right, okay, so so there is a formula which involves Ohm's law lah, which is V equals to IR. Again, it's not shown in your notes. Not that it's not shown lah, except that this one. Okay, it's in page 91. Okay, page 91. There is this defined resistance, and then at the bottom here, write the equation for Ohm's law. So you write the equation over here lah. Okay, at the bottom of page 91. So Ohm's law equation is just the potential difference is hasil darab of the current times the resistance. Okay, so this is V is the potential difference, I is the current, okay, and R is the resistance. Okay, what actually is resistance? We have to look at the experiment lah. Okay, sorry, potential difference. Okay, and the good news is there's a very easy way to remember lah. Okay, if let's say you use the Ohm's law triangle, okay, you put V up here and then I over here and then R over here. So kalau kamu mau cari V, bahkan kamu tutup V, so V equals to I times R. If you want to find I, then you tutup I equals to V over R. Or if you want to find R, you tutup R, then it's R equals to V over I. So if it helps, you can use the triangle to help you to remember the formula for Ohm's law. Okay, but I think that V equals to IR is actually very easy to remember lah. Senang lagi daripada kamu mau ingat ni segitiga. But some people like the segitiga lah. Okay, now these are some basic devices and symbols that you will see in your journey in electricity. So I need to remind you lah, okay? You should actually know this, but I just want to remind you. Okay, so a circle with an A is an ammeter. Ammeter is used to measure current. Okay, a circle with a V is voltmeter. Voltmeter is used to measure potential difference. Okay, now take a look at how the voltmeter and how the ammeter is arranged. Okay, the ammeter is arranged, arranged in series. Dia selalu bersebelahan dengan mentol lah, rintangan lah, a wire. Okay, but the voltmeter, okay, is always arranged in parallel. Okay, to whatever the alat is over here. So if let's say I want to change this resistor. Okay, this is a resistor. Okay. Resistor is dalam bahasa Melayu dia panggil perintang lah. The symbol for resistor is just a square. Okay, another symbol for resistor is this. Okay, this is also a symbol for resistor. So square like this or like this, these are both resistor. So ammeter is always arranged next to or at least dalam baris yang sama, okay, dengan the resistor or the mentol. If I want to change the resistor to a mentol like this, same thing lah. Okay, but the voltmeter is always arranged in parallel. Dia mesti ada line kedua. Okay, cawangan kedua lah. Bukan dalam laluan utama tetapi dalam cawangan kedua. Okay, that's where the voltmeter will be. Okay, yeah, see perintang is here, or it can also be a rectangle. This is also the symbol for resistor. Okay, battery cells, it can be yang kita tahu kaki pendek is kaki negatif and kaki panjang is kaki positif. Okay, this is a symbol for a switch. Okay, the switch, the function is to turn on and turn off the circuit. Okay, constantan wire is just the same. Okay, this is a rheostat. A rheostat is dalam bahasa Melayu kan, rheostat is perintang boleh ubah. Okay, so it is like a resistor. Okay, it is like a perintang, except that it can change the resistance. That's why you see the symbol is almost the same. Okay, except that it has an arrow over here to show you that it can be changing resistors. Some books, they also give rheostat like this. This is also rheostat. Okay, resistor yang boleh ubah-ubah. Okay, the one with the arrow over there lah. Okay, I'm going to move on now since got no response. Okay. So when we talk about resistance, this is question number 1. Define resistance. Okay, resistance is actually the ratio, ratio of voltage or potential difference, to current. Okay, the answer for number 1 in page 91, define resistance. Resistance is actually the ratio of voltage to current, because from Ohm's law, V equals to IR. If I move the I across, it will be V over I. Okay, so that's the definition for resistance. Okay, so remember that when we were talking about voltage, voltage is how much energy you have to travel across 2 points. And from that energy comes the current. Okay, the current is flowing lah. Okay, and resistance, dia punya nama adalah rintangan. Okay, rintangan, the old language for rintangan is halangan. Okay, it is basically apa yang menghalang cas daripada mengalir. What is obstructing, what is resisting the current flow? Okay, that's the resistance. Okay, so the voltage provides the energy. Current flows. Okay, and then the resistance is trying to stop the current flow. Okay, and this picture is a very good example. Okay, if the resistance is a lot, okay, then the current flows very slow. Currently, I'm not traveling very fast. This is a pun. Okay, dia sengaja buat pun di sana ini. Dia adalah current, and currently I'm not traveling very fast. Wow. Okay, and the voltage is always trying to give energy to the current to flow. Okay, and the voltage does this by having a certain potential difference lah. Okay, so cas melawan rintangan apabila mengalir melalui konduktor. Okay, so the charge, all charge, when charges flow, they always have to go against a certain resistance. Okay, when they want to flow through a conductor. Okay, so this arrow ini menunjukkan the arah aliran arus, okay, the current flow. Manakala these are the molecules inside your wire. Okay, wire is pepejal bahkan. Okay, wire is solid. Okay, so the arrangement of the molecules is actually very close. So because of that, when current flows, they are going to bang into all these molecules. Okay, and that's where your resistance comes from. Okay, and so the unit for resistor is ohm. Okay, and written sebagai symbol omega. This is omega lah dalam bahasa Greek. In Greek, this is called ohm or omega lah, fine. Okay, but ohm, because the guy who found this is called ohm. Okay, so ohm. It looks like a horseshoe lah. Okay, so just to recap, potential difference, the symbol is V, the unit is V. Okay, for volt. Current, the symbol is I, the unit is A for ampere. Resistance, the symbol is R, and the unit is ohm. Okay, ohm. Bukan, yeah, ohm. Okay, So today, what we're going to do is we're going to look at two different types of combination circuits, which are called series circuit and parallel circuit. So we're going to look at activity 1 in page 91. Okay, so this is where, sorry, this is where, oh no, this is where you need to write stuff lah. So this is what we call a series circuit. Look at the resistors, R1, R2, and R3 are all arranged in the same flow of current. Notice that they are all arranged in one flow, okay, one after another. Manakala, in a parallel circuit, the current flows and then dia akan bercabang. Okay, it breaks into three or more lah, okay, different cabang lah. Okay, and this one is what we call a parallel circuit. So this is a series circuit, okay, on the left hand side, and this is a parallel circuit. Now in the series circuit, since they are all in the same current flow, okay, so the current that flows through R1 is the same as the current that flows through R2 and is the same that current flows through R3, which is the same value as the main current. Okay, because dia dalam satu laluan. Okay, so the current flow is the same. Walaupun dia punya resistance mungkin berubah, okay, tapi the current flow is the same. Okay, secondly, in the parallel circuit, okay, the current flow, because di sini kan bila dia sampai di sini, it has to break into three parts. Okay, so in this parallel circuit, the current is different. Okay, current is divided. Mungkin dia divided equally, mungkin dia akan divide mengikut dia punya resistance lah. Okay, this is a very important thing. And so the total of I1, I2, and I3 will give you the value of the main current. Okay, because in a parallel circuit, current is divided. Secondly, the voltage. Okay, in a series circuit, the voltage is divided. Okay, the voltage yang dibahagi. Okay, that means from here until here, okay, jumlah voltan yang melalui di sini adalah sama dengan the main voltage over here. So V1 plus V2 plus V3 will equal to this big V over here. Okay, manakala in parallel circuit, the voltage is the same because they are traveling from this point to this point. Remember, our voltage is how much energy you need to travel between 2 points. Okay, and since R1, R2, and R3, the 2 points are about the same length. Okay, so the voltage will be the same. Okay, and this is the first and most important thing that is the difference between series and parallel circuit. In a series circuit, the voltage is divided. In the parallel circuit, the current is divided. Okay, dia adalah terbalik. Okay. Now, lastly, how do you count the effective resistance? Okay, the effective resistance atau dalam bahasa Melayu dipanggil sebagai rintangan berkesan. Some books will call it as total resistance. Okay. Jumlah rintangan lah. Okay, jumlah rintangan. Now, in a series circuit, the total resistance is very easy. Just R1 plus R2 plus R3. You get the total resistance of the whole circuit. Okay, but in parallel circuit, it's a little bit different. You have to use salingan. Okay, 1 over R1 plus 1 over R2 plus 1 over R3, then you get 1 over R. Then when you get 1 over R, then you have to terbalikkan. So, when you copy this down, I want to suggest that you put a star over here. Okay, because there is another extra step you want to count. Okay, to find the effective resistance. And we will do a couple of examples after this. Okay, can I carry on? Saya balik-balik tanya ini kan, tapi tidak orang balas.
Okay.
Boleh, sir. Yes, Boleh. sir.
Okay.
Yes, sir.
Yes, thank you. Okay, so let's take a look at this. Let's consider this first. Okay, I want you to make sure that you understand the difference between series and parallel circuit. Remember, series circuit, okay, the current is the same. Parallel circuit, the current is divided. Okay, think about this. All right, let's look at question A. This is only one lah. Okay, so the question is, give me the reading of this current. If this ammeter is 1 amp, this one will be also 1 ampere lah, because it's the same, this one. Okay, question B. Current flows through here 0.5 amps. After it flows through 2 light bulbs, what is the current reading over here? The current reading over here will be 0.5 amps, because it is in series. In series, the current is the same. Okay, in parallel, the current is divided. Okay, now what about this? Over here is 3 amps. Lepas dia break up, okay, and then it comes back here. What is the reading in this ammeter? It will still be also 3 amps, because dia sudah pecah dan dia sudah join back together di sini. Okay, so it will be 3 amps. Okay, now I want you to take a few minutes, take a look at D, E, F, and G, okay, and tell me what is the value of the ammeter reading. Okay, think about what you have learned. Remember, series circuit, same. Parallel circuit is divided. Okay, I give you 2 minutes. Take a look at these pictures. Tell me what is the value of D, E, F, and G. And then I will call your name. To the answer. Thank you. Okay, all right. Let's begin. Can I have Miss Tian? Miss Tian for number D, Valerisa for E, Lester for F, and Daniel for G. Oh, got H. Okay, Damir, H. Hold on. Let me remember. Kau selalu saya panggil nama kan, terus saya lupa. Okay, Tian over here. This is Valerisa. Nah, tengok siapa yang F tadi tu?
Lester, me.
Oh, Lester. Okay, Lester. G is who? Oh, I know H is Damir. Siapa yang G tadi tu? Who did I call out for G just now? Oh, Daniel. Okay. Let's see what your answers are. Oh, okay. Go ahead. Tian, what is the answer for D? Okay, the answer is 3 amps. Good. Let's, Valerisa, E?
5A.
Okay, good. 5 amps. Biasakan diri dengan menggunakan perkataan amp, ampere lah. Okay, Lester?
2 amps.
2 amps. Good. Daniel, G? Daniel, Damir H berapa? Oh, this is very interesting. Actually, Damir kena tahu jawapan Daniel dulu. Daniel, you need to give your answer first. What's the answer, Daniel? .5 amps. Nope, it's not 4.5 amps. Okay, let's consider. The main current is this one, 3 amps. So it cannot be 4.5 because the biggest amount is 3 amps. Okay, so we have 3 amps flowing over here. And then over at this point, this is where it breaks up. Part of it goes here and part of it goes here. If part of it goes to 1 amp, so this one will be 2 amps. And this will be 2 amps. So 2 amps is flowing over here. Then come to here, it will break again. Over here and over here. Okay? And since this is 0.5 amps, Damir berapa ini? Is Damir even here? Damir.
Sekejap saya. 1.5.
1.5. Okay, because after the 0.5 comes here, it will combine with the 1.5 and come back to 2. So over here is 2 amp. At this point, it will combine with the 1 and you will get 3 amps again. Okay, that's how current flows in a parallel circuit. Okay, you need to consider all the factors. All right, it starts from the battery and goes one whole round all the way to the battery again. Okay. Oh, ada pula jawapan di sini. My goodness. Okay. Now let's talk about the potential difference. Remember, potential difference, the battery is where the main voltage is. Okay, but in potential difference, as I mentioned before, potential difference, the series circuit, the potential difference is divided. Okay, so take a look at this. There is A, there is B, there is C, there is D, and there is E, and there is F. Okay, remember, potential difference, series circuit is divided. Parallel circuit is the same. Okay, take a look, and then I will ask you once again. A, B, C, D, E, F. Okay. Right, let's have A, B, C, D, E, F. A for Eliska, B for Brandon. Sorry, there's nobody in C in this class, right? Okay, Irdina C, Isabella D, Crispy saya sudah panggil, Louis E, and Michelle F. Okay, A for Eliska, B for Brandon, Irdina C, Isabella D, Louis E, and Michelle F. Okay, A please.
1 M.
Okay. Wih, mana boleh M? Sister,
V.
voltan. 1 V. Okay, 1 volt. Okay, B for Brandon.
5V.
Okay, 5 volts. Good. C for Irdina.
6 volt.
Okay, 6 volts. Dia satu kali jalan bahkan. So, is 4 volts plus 2 volts. Very good. D. Who is it? Isabella.
3 volt.
Okay, good. 3 volts because the total voltage is 6. So it has to be 2, 1, and then 3. Okay. E. Who is E already? Is it Louis? Louis. Yes.
4V.
4V.
Wait.
Oh yeah, you're right. No, cannot be. Cannot be.
Not sure, Cikgu. Not sure, sir. I'm not so not sure.
Okay. It's okay. Michelle, tell me first. What is F?
2.
Okay. F is 2 volts. Actually, Louis, E is also 2 volts. Okay. The best way to think about voltage is from point to point. Kalau here is 2 volts, here also is 2 volts, therefore here also is 2 volts. Okay. If my voltmeter, why can't I rub this off? Okay, if my voltmeter I put over here, okay, if I only put it on one bulb only, then it's slightly different. Okay, I will get a reading of 1 volt, and then over here is 1 volt. But the total voltage from point to point here is always the same as the total voltage from the battery to battery. And that's the good thing about parallel circuit. Okay, the battery is the same. So just like this from this point to this point, okay, is 3 volts. Therefore, from this point to this point, the total must also be the same. That's why when we draw circuit, we always draw in square. We don't draw squiggly lines like this. Okay, it's very hard to see, Okay, we always draw in square, so that we know, oh, this point to this point, the voltage is the same as this point to this point. Okay, all right, good. Now, let's consider how to calculate the effective resistance. Okay, so in this case, these are three resistors that are connected in series. They're bersiri. Okay, so this will be 20 plus 10 plus 5. You just add them all together lah. So the total resistance is 35 ohms. Remember, the other word for total resistance is effective resistance. It's the same meaning. Okay. Now, if it is in a parallel circuit, we have to do something slightly different now. Okay, 2, 5, and 10. So the formula tells us that it is 1 over R equals to 1 over 2 plus 1 over 5 plus 1 over 10. 1 over 2 plus 1 over 5 plus 1 over 10. When you add this together, you get 8 over 10. But this is 1 over R equals to 8 over 10. Effective resistance is not 1 over R. Effective resistance is R. So how do I find R from here? I just flip it around. Okay, I will get 10 over 8, which is actually 1.25 ohms. That's why just now in the slide I told you, sorry, I have to go back all the way. Okay, in this slide I said, this one you must put a star because you need to remember that effective resistance is R. But for a parallel circuit, when we calculate effective resistance, we have to use a slightly different formula. Okay, there's a very long-winded explanation to this now, which you don't have to know now. Okay, if you are going to study electrical engineering in the future, then you can study this lah. Okay, so this will be 1.25 ohms. So you can write a reminder over there in your notes over here lah. Okay, for the parallel circuit make sure to flip the R. Okay, kasih terbalikkan the 1 over R. Okay, to find R. Okay, don't forget that. All right, now we have combination. Okay, like this. This is 10, this is 20, and then you have 2 in parallel like this. Now, when you see a situation like this, you have to ask yourself, okay, which one is easier to count? Okay, of course, you have to count the series one lah. But since these 8 and 8 are in parallel, okay, what you do is you find the R for this first. Okay, and that's what we will do first. So 1 over R equals to 1 over 8 plus 1 over 8, we should get 2 over 8. But I want R. So 1 over R equals to 2 over 8. So we have to flip the R. So R equals to 8 over 2. 8 divided by 2 will be 4 ohms. Okay, so these two resistors dia punya jumlah adalah 4 ohms. Okay, and so I can redraw this circuit to become like this: 10 ohms, 20 ohms, and 4 ohms. 10, 20, and 4. Because these two 8 ohm punya resistor, when I calculate the effective resistance, is actually the same as 4 ohms. And then this makes it very easy for us to count, really kan? 10 plus 20 plus 4, because this is in series. So my answer will be 34 ohms. Okay, so when you get a combination like this, try to settle out all the smaller circuits first. Okay, and then you find it easier to count later lah. Okay, now in situation D, you have 2 in series, 1 and then 2 in series, but all these 3 are in parallel. Okay, so maybe the best way to calculate this would be to short form this, do 3 like this. Kan? So these two in series, bahkan in series kita tambah saja. So 8 plus 8, this will be 16 ohm. This one is alone lah, so it will still be 8 ohms. Manakala this one 4 and 4, since they are in series, you add them together first. Okay, then you get 8 ohms. So you get 3 single resistors that are in parallel. Then you can calculate in parallel already. Okay, 1 over r equals to 1 over 16 plus 1 over 8 plus 1 over 8. Can you calculate and tell me what's the value of r, please?
3.2.
R is 3.2.
Yeah.
Are you sure? Okay, so R equals to 3.2. Sorry, I forgot to mention. If you guys don't know where this page is, this is now in page the muka surat, but it's after the graph paper lah. Okay, question D. Okay. Okay, so the answer for this is 3.2 is probably correct lah. Okay, yeah, 3.2. Okay, so question E and question C are almost the same. You do the parallel one first, and then you kasi campur. Okay, I'm going to continue because I just want to give you the hint first lah. Okay, and then you try to answer the questions on your own. Oh, no, don't show the answer. Oh, no, I cannot do this without showing the answer. Okay, so you know what? I tell you what lah. Can you, for next week's class lah, okay, I want you to try to practice question E until question J first. Yeah, E to J. Okay, E, F, G, H, I, and J. So 6 questions. You do 2 questions one day, out in already. You can do all 6 today also lah if you want. Then you can have the weekend to rest and relax and don't think about this. Okay, this subtopic is very big so I need to go slow lah. Saya besar mungkin sebelum cuti saya akan habiskan subtopik ini sahaja. Itu pun the experiment pun saya rasa belum selesai lah. Okay, so please answer question E until question J for our next class.